So far in this roadmap, we've been working with single pieces of memory. We did one temperature value, one battery level. We did one variable at a time. But in real systems, almost never work with just one value. If you have a drone doesn't read one sensor measurement and then stop. A hospital monitor system doesn't capture one heartbeat and then quit. Real systems deal with collections of information. And this is where lists comes in, and that's going to be the subject of this video. So let's start simple. I'm not going to use list. I'm going to start with imagining that we have to store multiple temperature readings. The way to do this, we're going to be basically writing temperature is equal to, let's say, 22. And then again, temperature is equal to 20, 25. And then temperature is equal to 27. And then temperature equal to 30. Okay, so this is without list. We would have to create separate variable for every single value. You can feel there's a problem here. What if we had 100 readings? What if we had 1,000, 10,000, 100,000 readings? Managing separate variables becomes impossible. So instead of storing values separately, we're going to group them together. And this grouped collection is called a list. So let me show you how that works. We're going to delete this and we're going to call temperature equal to, we open a bracket and then add the temperature values, temperature 25, 27, and then you have 30. Let's slow down and unpack this carefully. Let's just call first this temperatures. The variable name is temperatures. Inside these square brackets, we have the temperature values. So we place multiple values together. Each value is separated by a comma. So a list is simply a collection of values stored in one place. You can do any kind of values, not necessarily temperature. For the sake of this example, we picked temperature, but it could be any kind of list of values. Let's print it out and see what it's going to look like. Here you go. 22, 25, 27, and 30. Now our system memory is organized. And instead of 4 separate variables, we have one structure containing multiple values. And this changes almost everything because now our programs can begin working with real collections of data. But something interesting is happening here. So even this list looks like a one object, Python still keeps track of every individual value inside it. And to understand this more deeply, we need to understand how Python finds each item inside this list. So inside the list, every value has a position. That position is called an index. And this part is very important because Python counting from 0. It doesn't count from 1. So the first item here, which is 22, is not at position 1. It is at position 0. So it starts at position 0, 1, 2, 3, like this. It's not 4. So internally, Python sees the list like this. 22 is at position 0, like this. And then 25 is at 1. And then 27 is at 2. And then lastly, 30 is at 3, like this. Okay? Just so that you can see it. Let's access one specific value from the list. If I want to access this temperature value, how do I do that? We're going to print temperatures. We're going to call the variable. And then inside the variable, I want to call position 0. Run list 22. This syntax means go to the list called temperatures and give me the value at index 0. If I change this to position, let's say 2, which here is 0, 1, 2. So I'm calling 27. And then I'll say run list. Okay, 27. So this time we got 27 because 27 is stored at index 2. Think of a list as like a row of numbered storage boxes. And Python doesn't search by value first. It searches by position. Also, one thing to understand, Python can count backward, not just necessarily for calling the values, but you can actually call it backward. And the way to do that, you just say -1. So run list. So -1 means basically give me the last item. And when we run it, we get 30, which is the last item. Now we can access from the front and from the back of the list. And this is why lists are very powerful. We're no longer storing random variables separately. We're organizing structured memory where every value has a known location. So far, we've only been reading values from the list, but real systems are dynamic. You have new information arrives, you have old information changes, data gets added constantly. So this is where lists become extremely powerful. Right now, our list contains 4 temperature readings. But what happens if a new sensor reading arrives? We don't want to rebuild the entire list manually. For example, I don't want to go and just create another temperature variable like this, and let's say add 45, and then another reading comes in, let's say 50, and I add 50. There has to be some way that is more automatic and easier to do. There is a way that is easier to do it, which is using something called append. So let's write it down. And instead of writing here the new variable like this manually, let's do it this way. We'll say temperature. Okay, I'm calling the variable, and I'm saying append, and then I'm adding, let's say, 33, okay? And then here, I'm just going to print temperature. But before I print it, let's just unpack this slowly and carefully. Temperature is the list, as you know it here. Temperature is the list. Append is an action attached to the list, and inside that, the parentheses, we place the new value we want to add. So this line means this. Take that value and attach it to the temperature list at the end of it. Let's run the code and let's see temperature list after appending the value 33. Here you go. 22, 25, 27, 30, and 33. As you can see, the list has grown, and this is very important. Lists are mutable. Mutable means they can change after they are created. And here, we're not limited to only adding values. We can also change existing ones. Let's point out here, the 25. Let's say 25 was incorrect. Maybe the sensor calibration was off. Okay, so what does that mean? Let's remove the 25 or replace the 25 with 26. How do we do that? Well, the way it's going to happen by calling the temperature variable and then calling the position, which is right now we're at position 0 is 22. At position 1 is the value 25. So we're going to call position 1, which is 25, and I'm going to say equal to 26. So basically here what I'm saying is this. Go to index 1 and replace the existing value with 26. Replace 25 with 26. Let's print it and see what happened. Here you go. 22, 26, 27, 30. The second value changed from 25 to 26. So lists are not static memory. They are living collections. They can grow, shrink, update, and evolve over time. And this is exactly how real systems behave. You have sensor readings update, whether it's data set that is growing, logs expand continuously, and lists gives us a way to organize all that changing information. But once we start storing larger collections of data, we quickly run into another problem. So how do we process every value efficiently without writing the same code again and again and again? Our list can store many values, but imagine if we had 100 readings or 1,000 readings or live data arriving continuously. We can't manually print every value one at a time. That would completely defeat the purpose of organized memory. So instead of manually accessing each value here in the variable temperatures, we can combine lists with loops, and this is where programming becomes more powerful. Let me create a for loop that automatically goes through every value inside this list. So the way to do that, we're going to say for temperature, just a single temperature, a single value temperature inside the temperatures variable, okay, print the temperature value. So what I'm doing here is this. This line here is saying this. For every value inside the list called temperatures, this one, which is that variable, point to the first temperature, that one, which is the first value, temporarily store that value, which is, let's say, 22, the first one, in a variable called temperature. So this variable changes every cycle of the loop. First temperature is going to be 22, then 26, then 27, 30, 33. Now, inside the loop, as you can see, I can work with each value individually. So this is supposed to give us every single value here, one after another. Let's print it out, and let's see if that's true. Notice what happened. The loop automatically moved through the list, first 22, 26, 27, 30, and then 33. So this is not random repetition. The loop is pulling one value at a time from the collection. And this pattern exists everywhere in engineering. If you have a system that reads a stream of sensor values or process network packets or analyzes AI training data or scans system logs, one item at a time. And now that we can process every value, we can also make decisions about those values. And that's where conditions comes in. Let's actually add a condition here. Let's do this. If temperature, okay, if that single temperature is greater than 30, let's print high temperature detected, and then I can just show the value of that temperature, okay? And then else, if anything that is below the degree of 30, then just print normal temperature, and then I need to mention the value as well. So now the system is this. You read the data, then you evaluate the conditions, then you respond. Okay, so let's run it. All right, so we have normal temperature at 22, 26, 27, 30, but then because we have this condition, if it's above 30, which is 33, then I want you to print high temperature detected and then give me that value of that temperature. So this is the foundation of data processing, not just storing information, but actively analyzing collections of memory.